Good morning all. So today we will study the RLC circuit to understand its phasor diagram. So we will study the phasor diagram for RLC circuit. As we understood the electrical quantities both for the time varying waveform and also phasor representations. So we are at the correct stage to understand the phasor diagram of one RLC circuit. So if we draw one series RLC circuit and if we feed that series RLC circuit by one sinusoidal waveform, that is V equal to Vm sin omega t, say, then one current will be flowing through this circuit and that will be, say, I. Now the resistance is R, inductance is L and capacitance is C. Those three will exhibit their own property towards this sinusoidal excitation. Now how the resistance will behave? So resistance, inductance and the capacitance, they individually show their response or show their properties towards the applied V generated I. Means the V will try to generate some I or current, and that current will try to be conducted through R, L and C, and whenever it will try to conduct, it will face three different kind of properties, and the properties exerted by any electrical component, either R, L or C, towards an alternating current is called impedance. So the impedance, which is denoted by Z, that Z or Z is the property of R, L or C, either individually or collectively, are the property by which they try to oppose the electrical current to be conducted through it. So R will also show some impedance, that is called, say, ZR or ZR. L will show some impedance, that is, say, ZL, and C will also show some impedance, that is called ZC. So for the resistance, ZR will be R. For the inductance, ZL will be JXL, and for capacitance it will be minus JXC. J stands for the root over minus 1, and it is making one number or converting a number into its imaginary form, and whenever it is associated with any real part, then it will make a complex number. Now for understanding the RLC circuit phasor diagram, let us study the behavior of the basic components of an RLC circuit, that is R, L and C, exerted towards the AC excitation. So here we will discuss about the AC excitation on R, L and C, and also their combination. So there are three elements in one RLC circuit, that is R, L and C, and we will excite that series circuit by AC voltage source, which can be considered as V is equal to Vm sin omega t. So now the voltage connected or voltage source connected with this circuit will try to send one current, and that current will be I. Now this current is passing through R, passing through L and passing through C. So the current through R is equal to IR, say, through L equal to IL, and through C, IC. Now from this series circuit it is obvious that IR equal to IL equal to IC equal to I. And also, due to the conduction of I through R, L and C, there will be voltage drops across each element. So for voltage drop across R is, say, VR. For L, let us see, it is VL, and let us call the voltage drop across C as VC. So now in the Phasor diagram of RLC is nothing but the Phasor diagram between these three quantities, and these three quantities are actually this quantity, means the phase angle between VR, VL, VC and I. So we will have to draw the Phasor diagram between VR, VL, VC and I. So this will be our task now. Now for executing this task, we will start with the understanding of phasor diagram for individual element under an AC excitation.